So, here's what happened. We were missing a bunch of people because of orchestra or whatever else. Some of us did 514. So, excuse me, I want to talk about it, see what we need to do on it, see if we're good, and then we got to figure out homework because some of us were here that day, some of us weren't.
3 of us
You
were
should
here.
just not assign homework.
It was me, everybody, Jenny. Everybody else was not here. Because we were watching a math documentary.
That was fun.
Hey, but you were here?
Yeah, so some of you guys did your homework while we were watching that documentary.
No, we didn't.
I think
I did
Colin
find
said
an
that.
extension.
No,
Or
yeah, I
extended
think he did his.
Hey, but why weren't you at the band?
Because I didn't want to go.
Besides, we also had dinner.
Oh, yeah, it was the OSU band day. That's why you guys weren't here, not orchestra.
What's the date today?
It's 27.
So, if there are only 3 of us here that day, this is really what your homework is tonight. If it's already done, wonderful. If not, do it. So now we're getting to like, what's the point of quadratics? What's the point of parabolas? What do we do with them? What are they? So we're dealing with tables, equations, situations, graphs. Oh. Sorry, we were chatting and then I just like naturally started talking about stuff.
Sorry, I'll remember stuff.
When does this class start?
33.
Yeah, you're not late. I don't get to start for another 5 seconds. It's gonna be technical. That's a nice hoodie. I like it. Your hoodie.
Go.
Go! Yeah.
We're working on 5.1.4, right?
Yes.
I distinctly remember going through it. Yeah, me too.
It
I remember you, like, we were working
That's
through it.
what I was trying to figure out. So,
I think
Right, done it
has
with you.
everybody seen this?
Yeah.
Because different people were in and out. Okay, that's what I thought. So
We
515
Orchestra was here
takes
like
that and extends it. What's up?
This just weird me out. Every time I walk by,
All of them.
I'm like, why is the door wide open?
Actually, the best thing was when Ava walked in, she was like, Mr. Hudson, why does the door look different?
Yeah.
Because it is different.
Yeah, I thought
So- So now that we've talked about that stuff, we're going to extend that up. So, okay, if we've done 514, who can explain to me, or did we get to the point of really why we use parabolas? Why in physics parabolas are really important?
No.
Have you ever seen this number?
I've seen it before, but I've
Yes.
never used it as like a good reason.
Oh, yeah.
No.
Wait, I know one thing about
Or some people write it.
Yeah.
I've never seen
Yes.
Gravity. Yeah. Everything
Oh.
travels in a problem. Even if you throw it underwater. It just goes.
So, gravity, right? Because of gravity, when things go up, they have to come down, and that happens in a parabolic arc. So a lot of these situations that we're going to be talking about deal with objects moving, objects falling, objects being thrown. It's really the basics of physics. So previous lessons, we've almost completed our web. So we didn't make a poster because there's 9 of us and we don't really need to, but we talked about all this. So we are now going to look at these parabolas. Match each graph with the equation that would go with it based off the things that we've talked about. Negative will do what, A will do what, B will do what. We talked about all these shifts. So work with your team. Figure out which function matches which graph.
So one has to be a positive I mean, that makes that a lot easier. Well, we got one of them found out. That's a victory in my book.
All right. Let's give you a hint for just a second. I'm not going to give you any answers. Who can tell me what A does? The coefficient of x squared. How that affects the graph? It does two things. Colin, you want to give me one?
One thing, if A is negative, the parabola is like this. Like if you threw something across one, that kind of parabola.
Yeah. Positive opens up, right? It's going upward. Negative opens down.
Yeah.
Do you know what the value does then? The actual number does what?
Can't quite remember.
It rises, it lowers the parabola.
What do you mean?
Like, wait, which?
You mean like vertical shift?
Yeah.
Well, so C is our vertical shift, but this number. So we talked about whether it's positive or negative, whether it points up or down. But what about it's like what 2 versus 8 versus 80?
Does it? I mean, no. The coefficient of just x, like.
No, A. We're still talking about A.
I know.
Yeah, so like the intensity, the slope, the steepness, right? So we can kind of, I mean, it is slope, but in this case it doesn't stay constant, but it is the slope at any given point. B's really awkward.
It moves it in a parabola.
Moves it in a parabolic fashion.
Oh right, yeah, we worked with that the other day. Not reading. Like the vertex of the parabola is moving along.
When we looked at it in Desmos.
Yeah.
Do you remember that? All right, so now back to trying to match those up.
But how do we know if it's vertical or if it's just C or if it's A?
C will keep it on the its axis that it's at, axis of symmetry. B will shift it to the left or the right and vertically. Your team gets a 1 calculator to work together and help you verify and or test and or just if you're stuck, just to plug it in. Don't forget about your trace button.
There's 9 queens, 6 dragons. So why minus 9 if you go to 6, then why not 10?
So we've been off for a few days. Remember how to work the calculator and help each other out. You're welcome. I didn't realize this until I looked at it. My one Pyrex thing has been well used. The little one, you can still read the lines, but the big one. Okay, sweet.
Yeah,
Hollis, let me speak. You speak now. Explain what you were going to say. It's C value is positive. Well, if you look at this, it should be negative, and I is a negative one. Okay. Through the process of elimination, it's the only thing that works. But just because it has the greatest slope does not mean it corresponds to the graph with the greatest slope. It might not have a graph. While it is true that it has one here, that's not always true. It's not true. For some reason, it can help back you up. You can't use that as your sole reason. I think is what you're trying to say.
Yes. It's a valid, that's a sound argument right there.
I tried to stop from a petty
You have
argument by having
6 inputs, or you have 9 inputs and only 6 outputs. Some don't exist, right?
Let's try to find the other one. 1, 2.
Oh, and a 4 is
right now.
definitely G. I just worked it out.
Because what you do is you take the x, the value, the x initials, and you take the inverses of them, and then you make that into
Very low. Well, actually, there's no vertex, and it's very easy to calculate. which one?
It has to be 2. That could be 2. That could be negative.
No, but define that as technically because there's no scale. I see what you're saying.
Yeah, and yeah, when I back subtract your thing on mine.
So do we want to?
No, but it would have to be because that's the half plus with the 3, 5, and 6 negative. No, we know it's -5. We just don't know how far. We don't know how. We don't know what the y is, but we do know what.
Are there any that we've all agreed on pretty easily? Any that? What do you guys have? 5 is D.
Yeah.
How do we know that?
Because it's negative.
Yeah, A value's negative, flips the parabola over.
It's the only one that has a.
The only one that it could possibly be. It's the only parabola pointed down. I heard a really good argument. Both sides of the argument were really good. This one has to correspond with the steepest graph, or the steepest, like, highest A. And a counter argument being not every graph is pictured, so not necessarily it still needs tested. Because they notice it's the tightest, the steepest graph. Okay, so any others that we all agreed on? Have we tried utilizing the zeros?
What?
The zeros. Remember that last week we talked about the zeros are inputs to the function, whereas if I set up my binomials, wasn't that, so this would be x. Ooh, so -7 makes it 0. This would be +7, and this would be. Then if that was it, with no extra values out in front or anything, we'd get x squared plus 3x minus 28. So I think one's B. Try utilizing your zeros. See if that'll make your life easier. You know, I was going to say we could just barter. How many pretzels? Have we figured out 2? What is it? E. Oh. 3 has A 0.
Because we graphed it.
Yeah. I think you got it. Since 3, either that or she just got my bad humor. I said 3 has A 0. Like 1, but also so 3 is A. Stop it. Because we know x plus 3, but how do we get to x plus 3 squared? Isn't it just
a quadratic?
Has to be a quadratic, and still value of -3 makes that 0 because 0 squared is 0. Do we have 4 and 6?
Yeah.
What's 4? G. What do we do when we have a 0 that is 0? It's x plus nothing, or just x. So when we have an x of 0, remember that we can just have x, and then we'd have x minus 4, and then we work from there. 6, do we have 6?
Yeah, it's I.
I? Any issues finding that? Any questions
How did you find
on for 6? So, anyone want to explain process for 6?
6, we graphed it. Wow.
You graphed it, so you use tech. Anybody have a way of not utilizing tech?
Yeah, you just do same process.
So, x,
Plus half, and then x minus half.
so then
Certain numbers.
certain numbers.
Yes. Wouldn't it just be 3 halves?
I mean, I set my equation up like that.
Oh wait, never mind. Never mind. Math.
Negative x, thank you, Gunnar.
Yeah, then plus, wait, no, minus 0.
Ooh, minus, careful.
0.7.
Product just multiply straight across 3/4. I know you have it, but it's silence from everybody else.
Oh, and we multiply everything by 4.
Whoa! Wait, that's how you do that?
Oh,
Well-
they added, okay, I got that part. I just didn't know we had to multiply everything by 4. That's why I was confused because I didn't see this.
Now, why do we know it's been multiplied by something?
Because the fraction only has the numerator on, and then the other factors have the 4 in front of them.
Do we know what this point is?
No, the vertex.
You actually, well, yes. But we actually don't know where that point is. So we right now can't be certain of the intensity zoom because we talked last week, I could just as easily, except it would look better, have a parabola like that. Do you need something, Rachel? Are you good?
I'm good.
Sweet. That has a vertex way closer. So this is going to bring up our focus. So to give you a tiny little intro of where we're going with focus, the focus is the point within the parabola at a very specific location where all lines will then become perpendicular to the horizontal. So, think of a flashlight. Anyone ever work with a mag light, mini mag light, any of the twistable flashlights? Now you can make the beam widen
Yeah.
or narrow.
I got
You are shifting the focus point. Or, well, you're shifting the point in the middle that is at the focus or not at the focus. Because if I shift my bulb inward towards the middle of the parabola versus if I shift it outward, it's going to change the beam of the light. Right? So we're not going very deep into that right now because we really need to move on. But that's where we're headed, is looking at the steepness. The only reason that we can connect 6 and this graph with I is we just realize, oh, it's 4 times. We don't actually know that for certain yet because this point was not given to us. But good deductive reason. All right, quality control. Try 550 with your team. I'll give you like 5 or 10 minutes.
Ordering a parabola, yes. Dear Miss Quadratic. Perturbed in Pennsylvania.
Perturbed. Have you never heard that word?
Yeah,
But I like them. They
It's like annoyed.
same letter.
Yeah, it's like
Remember that
peeved
from
off.
7th grade.
Oh, yeah, he sent me the wrong one.
saying that you
Okay,
can clear some
you're
bonus
fun,
fun,
right?
you can
You're
do
very
somebody's missing
good.
half a parabola and they're gonna mess up the same x-axis only once out of
5-0, guys. You don't miss
Why
out.
do we have to write a
parabola.
like a friendly response?
You don't have to write a friendly response.
Just like
What would you
you
say?
write
But don't write a mean one. Write a direct one.
They can just go.
You were not specific enough at
Not
all.
everyone can make their own parabolas.
Kid, you are not specific.
Garner, you need to count your blessings. The fact that you have parabolas. Some people don't have any.
What is a parabola?
You can just make parabolas.
Parabolas.
There.
Those are horror.
Higher here and here have to start making parabolas. Like nobody really thinks about that.
Nobody wants to get a parabola.
All right, let me talk about A. I hear some conversations straying. So, with A, what do we need to tell them? What are they missing? Are they could actually a good first question from a customer service stance? Is it your fault that it's the wrong parabola, or is it their fault?
Their fault.
Their fault, right? So, Colin, we explain. Say that again and explain.
You need the vertex of the parabola in order to make them function for it. Otherwise, if you have just the two x-intercepts, it could be a parabola like this or like this.
So I heard your group have a little back and forth about the vertex thing. What about the vertex?
We just need the y value.
Why did you specify you need the y value? Because Owen, you said that, right?
Yeah, so the x value, yeah, how to wear it. You can find it because it's always the midpoint between the two values of the x's. So like it's in between -6 and 1, so it's in the middle. So like with that example, it's in between them. So if you have the two with the 2 points that we have, which are the two x-intercepts, we will know the halfway point. So we'll know the x part, and then you just need to know the y to figure out if it's a negative or positive parabola.
The vertex point of your parabola is always going to have the x that is directly between your zeros, the midpoint. The y is what is going to tell you the intensity of the slope. Question?
So, but
Sorry, I drew on this one. We're talking about A, but I drew on
I
this
feel
one.
like that's not. So, do you want us to tell them how to find the vertex? Because we
No.
tell me how to order the correct parabola.
So the whole
Add a
find,
vertex.
there is no vertex until there's a parabola. There is no parabola, at least correct parabola for them, until they tell us a little bit more details. We probably sent them the parabola that has an A value of 1, right? Because that's the easiest to do. If we just tried to build their parabola, what would I use?
Negative x minus 1 x plus 6
So that would come out to be
X squared
squared.
Plus 5x minus 6.
Yeah.
but they told us that's wrong.
What?
So we must need to change the intensity. But when I multiply here, I can't just throw something in here, because if I just put something in A, it's going to affect everything. So I have to back up to here and change that. Now, once they tell us the y value, we'll be able to work with that, but we'll get there in a minute. So B, do you guys need a little bit more time with that?
Yeah.
Okay. Keep talking about B. Try to stay on task, please.
No, because remember about 3?
At size 0, yet I see no mention of this as the parabola in your pamphlet. Your compensation statement indicated that I need or net no matter what.
Well, your equation, your
We have to know if it's
We can ask
the
them.
You don't know if it's going to be
Like in the way that you rotate
upward
the
and
parabola motion thing. So
I'm
that
gonna
is
say your equation will be in this
No.
form.
so you would change the you would remove the b value because that moves it like this. So it moves it in the parabola function. So you would just yeah. So using the b value. Yeah, there's many different ways to do this.
No, that's great.
There's many different ways to say that. So because you could have it be like a sideways parabola or just a lower parabola. I think the way that we could do it is where the b value they could hit. That's not what it's asking. It's asking how they should
what do they need to place on their order form?
The equation that goes with the one set of parentheses squared. So like x plus or minus. What? Why is there? What are you?
Z. What if it's any number?
What?
We're going to talk about two different things. So first, I heard a couple things. I heard, oh, they just need to change the b value, or they need to shift it up or down. Be careful. Read exactly what we're answering. They want to know how to get a parabola that only touches the x-axis once, doesn't pass through, just intersects it at 5, 0. I heard a couple people say, well, we don't know if it's flipped up or flipped down or like that.
Like, we also need to know the y-intercept. So you have to make it to have it hit the correct spot.
Well, yeah.
They, from what they told us, they don't care whether it's pointed up or down. They don't care what the y-intercept. They just want the x-intercept
Yeah,
or the 0 to be 5, 0.
You can just write the equation that is like y equals the quantity, the sum of x plus or minus c squared.
Wait, so say again. Sum
X plus c
plus z.
c.
C.
Because that's the
Let's not use c since we use c for
Well,
the ax squared
okay,
plus b.
so n.
This is why I had said z.
N.
Put c.
Or at words squared.
What type of parabola do we call that? So quadratic is equal to 0. Like that's because we can make it equal to 0.
A parabola.
If this is what's happening and this is what we're doing, it's a square, right?
Oh.
This is a perfect square. So, but when we started solving them, when we found out that this only has one solution, we did it with the tiles. This, if made with tiles, I mean, we'd have to know what z is, makes a square. Not just a rectangle that can be factored, but it makes a square. So it's a perfect square trinomial. That trinomial that makes the parabola, that's a perfect square. All we care is it's only one value squared. So whether z is positive or negative, I mean here we would need x for them, b, their parabola, x what? Plus 5 or minus 5? Squared. And then if we find out anything about b or c or any of those values, then we can multiply out front.
Wait, what about those parabolas that go sideways?
We're not there yet.
Oh.
It's not gonna talk about.
Oh yeah, I know those. Those
You
are
said
the
yeah.
one-to-one.
We don't talk about that.
Isn't that just x
Parabolas.
equals and then everything?
Yes. Yeah,
Where
Graham,
everything's always equal.
you are correct. All right, C. Take a couple minutes.
I'm saying that they already have the parabola that they want.
Yeah. You sent me a picture of it every time I went to this parabola. You sent me
Every time.
So we already have the parabola right there. It's right there. We already have it.
Go to math.
So do you just want us to write how to find the equation of the parabola?
No, of this one.
You want to know how to compare x plus b If you already have one, then why do you want another one? Actually, can't we just say it for her?
Wait, so you just made it yourself, but you want
Exactly what?
Yeah. Basically.
what you're telling me.
It's like 6.2. No.
7.
6.5. 6.5.
Sorry, just like working from my phone. Sorry, I'm sorry.
It's more like 6. Yeah, it's like 6.3.
6.9.
6.4 or something.
Wait, but isn't it
Zero
over
point
to
five.
the side?
I think that they don't need to.
What?
I mean, that's the equation you get.
Yeah, I know.
Oh.
It's just that it's not.
Well, Well, we have to know how to find the y-intercept. How do you find the vertex?
-3,
How do you find the vertex?
oh, we just go like that. So, oh, is it, isn't it 2 plus 5?
What would we start with here?
Yes.
Or x-intercept.
Oh wait. So negative -0.5.
X plus what? X plus 3, x minus 2. Which would give us x squared
Plus x
plus x
minus 6.
minus 6.
Okay, so we just.
Now that's not right at all.
Oh gosh, dang it.
What's the first thing we notice about this parabola that wouldn't work with this equation?
Negative.
It's negative. So we need some kind of negative multiplier out here.
Is it negative 2? Is it negative 0.5? Wait, hold up.
Let's first agree on a point up here.
That's about.
How do we know the x value?
Well, the x value is the middle of the x values of the vertexes, so it's negative 0.5.
We are 5 wide at our x-intercepts. So the midpoint will be 2.5 in. So negative 0.5 is your x value. What about the y value?
It's a little under 6.
Greater, but less than 8.
7.
Is it 7?
Do we just want to say 7 to make it easy here?
Yeah.
I mean, they sent us a drawing. It's a little hard to tell. Let's just say 7. You didn't label your point, you get 7. Okay? They'll be happy. Thanks, Sal.
It looks like that parabola.
We're going to make it easy. So, what do we really, what can we do?
Well, we can figure out how to make that equation equal. We need to figure out how to make it so that if you make the x value 0, it equals 7.
Ryan, you working on solving this? You doing something related to class? So why are you doing what you're doing? You got any ideas
So
here?
x squared, is it just. I don't know.
So we know we need a negative multiplier out front, right?
Yeah.
If I do that, that's going to flip the signs of everything inside, right? Because I could say this is a quantity. When I apply that negative, so negative, negative, positive. What happens when I plug in negative half right now? If I just flip the standard parabola, just apply a negative up front, what is the value at the half? Well, what's negative 1/2 squared? Negative times negative makes positive fourth, but then the negative applies again. So we have negative fourth plus the opposite of our x, so plus a half, plus 6. Do you think they were trying to draw that it's at 6.25? So our assumption of 7, although it would have made things easier for us to look at, we were about to make things a whole lot more difficult. If that vertex point of theirs is actually just at 6.25, then we got it. All we had to do was throw a negative in front of it. When it's not, it's a whole lot harder, which is why we're not quite there yet. But so the negative, we knew it had to flip over. Try it out, test it out, see what happens. Questions? We didn't need any other steps for the coefficient because it worked out. Check out 51. What was confusing about it? Just that it just worked out.
No. But You said we aren't there yet, so.
Because it's not. Say that that was like at 12, like we knew it wasn't 6.25. Then we have to deal with the fact that that wasn't right. How do we modify our function?
We're gonna stop. Okay. So you write the graph you have right. The examiner says
Oh my gosh, how long is this water balloon contest gonna go on?
Until summer ends.
generous means so.
Oh,
We go 0x
I was
plus
thinking generous.
0
Can we just look at back at Jen's data and write the Pascal?
Stop.
Huh? This is so much different than how I used to teach things. It's just messing with me. I used to deliver, and then we would try it. Now you try it.
It really does.
Do it like every day now instead of
I still
like
don't
a really
look
rough
at
day.
Did you? Okay.
But you should, so
Yeah.
should start.
Oh wait, that works? Wait, I'm gonna make my hot air.
Just make sure we're all on the same page because we only have like 7 minutes left. Because we have an x-intercept of 0, we know we have a just x. Positive 8 x-intercept, we use x minus 8. Parabola is flipped, so we apply a negative out here. Work from there, test, is this vertex correct?
Justin, I have a question.
Yeah.
Is the graph completely accurate for the thing, or is it like we're checking the graph to see if it's good?
Oh, this graph reflects the data that she had.
Okay.
Yeah.
So, no.
What's the y value up here? Just make sure all count.
Like
32, right?
Actually, we can just plug in our equation.
Oh, I did that wrong.
Negative parabola. And what's the deal? X.
Oh,
Oh no. How did you fix it?
Plug in 4, it's 14. Can't be if the vertex is 32.
Oh wait, that's oh.
So it would be, right? Gosh, my smart board's goofed up too.
Oh, but I didn't
Actually, I
realize
don't know.
something.
Looks like I should probably use this 2x.
How do we change the
Well, I was thinking that I don't know if we can imagine this tag is 0.
Play with it. How do we get our y value at the intercept to be double what it would be? Because the y value that we're given is 32. The y value that we get doing what we know is only 16.
So we need to change these?
Okay, I mean, try it out.
Wait,
No, it's
You gotta be able to tell me specifically what we do.
so we need to put a coefficient on
Oh,
here.
you're going up. Why don't you go up? Why don't I calculate that?
Yeah.
We know the x value at the intercept, and that can't change. Or at the vertex, sorry, and that can't change.
So
I got the
And
highest.
then we know the y value that we want.
No, I did it wrong. Oh, I did it like that.
Double.
Shoot.
What are you using?
That doesn't work.
So if you get the 16, that's what it is.
Yeah.
oh nope.
Oh, nope.
Just made it like
Yeah, the double is loaded.
wait,
Like that was the equation.
hold
And
up.
then you make it the result with a 2.
Okay.
Not plugging for it. Pretty sure plus 2, right? You can't add the 2 with 2.
So the y value needs to be double
Wait.
what it's coming out to be right now. Actually, if we go all the way back to what it would be before we had the negative, it has to be the opposite of double.
I got it.
Oh no,
What do you think?
I just deleted
Well,
it
wait,
all.
so the equation would be y equals negative 0.5x squared plus 8x.
Negative 0.5x squared plus what?
8x.
No constant?
No.
Okay, how'd you get there?
Well, when I first graphed it, it was about 15-ish, a little over 15. It was almost 16. It's like 15.9 something. So then I tried negative 2x squared, but then that just
Does
gave
this
me
still
half.
work for your zeros? Sorry, just to
No.
check.
Wait, does it? One sec. What are the zeros?
0 and 8.
Nope. Because it's double now. Hold up.
So you're saying this doesn't really work out?
No.
I got
This is confusing.
Chris?
I got negative 2x squared plus 16.
So you doubled everything. So are you saying up here we could just apply a negative 2?
Yeah.
Because then that'd be,
Oh,
yeah, because you did 2 times that. Does it work?
because I plugged it in so it works for the vertex. Too.
So if we look at the original form of what we were given, we got a y of, well, would have been negative 16 if we hadn't done anything to it.
Oh, it does work.
We wanted a y that was negative 2 times what we had. And Chris is saying go up and just apply a negative 2 out here.
It works.
We are out of time. Trying to pick this up here tomorrow. Please try your homework. We'll probably not talk about anything else from the lesson. We'll probably talk about stuff from the homework. If you have any issues or questions or anything like that, practice this. Use Desmos if you don't have a graphing calculator. Okay? Desmos, whatever you want to call it. Thank you. Thank you.